So we're going to start with this direct substitution and synthetic substitution thing before we get to the lesson. Direct substitution is something we've seen before. And what that means is that's where we're going to substitute 3 in for all of the x values. So I want you guys to do that now. Go ahead and substitute 3 in and then solve for this problem using the substitution of 3. And then I'll explain what synthetic substitution is in just a minute. Maybe you've seen it before, but I'm guessing you probably haven't. But we'll talk about that in a minute. So go ahead and work on direct substitution right now. All right, take a minute to do that. Okay, so this first problem, we'd start with doing the exponents. So there's like 3 to the 4th power. That's going to be 81. And then we go 3 to the 3rd power. That's 27. And then we just have a 4 times 3. We can write that as 12. Next we have 2 times 81. That's 162. 5 times 27 is 135 minus 12 plus 8. And then finally we would do 162 minus 135 minus 12, that's 15 plus 8, is 23. So f of 3 equals 23. That's the idea for this problem. Now there's this other thing over here called synthetic substitution. And the way synthetic substitution works is first we have to treat it kind of like a division problem where we look at, okay, this is a 4th degree polynomial, so there should be 5 terms. And we see 1, 2, 3, 4 terms. There's 1 term missing. So we have to put a placeholder in there, and that's going to be a 0x squared.
Wait, Mr. Street?
Yes.
Sorry to interrupt you.
No, you're fine.
I got 47 on the direct substitution. Okay. I end up with 162 minus 135.
Mm-hmm. And then minus 12 minus 8, or plus 8.
Minus 12 plus, okay. Yeah, my mistake.
Okay, no, that's fine. That's fine. Just all the terms, yeah. So on the second part with synthetic substitution, what we do is we're going to take all of the coefficients here. So there's a 2, a -5, a 0, a -4, and a +8. And we're going to write all of those coefficients down. 2, -5, 0, -4, and 8. Then we're going to write down almost like an upside down division bar. And then the last thing we're going to do is we're going to take this, I'm going to do that in a different color. We'll take this x equals 3 here, and we're going to write that down outside of the upside down division bar. And the way that synthetic substitution works is we're going to take this first 2, and we're going to try and kind of drop it out of the box and put it down here. And then in order to put it back into the box, we have to multiply by the 3. Every time you cross this line, you have to multiply by 3. So we're going to say 2 times 3, and we're going to get a 6 there. And then we're going to add these numbers, -5 plus 6. We're going to vertically add. It's really weird, but what's going to happen is we're going to get a 1. And then we're going to multiply by 3 again. Then we're going to add 0 and 3, and we're going to get a 3. We're going to do this. We're going to do an example like this again. So I'm going kind of fast right now, but don't worry about that. We'll talk about it a little more. We do 3 times 3 gets us a 9. -4 plus 9 is 5. 5 times 3 is 15. 8 plus 15 equals 23. And the key there is using this direct substitution method, we ended up with the exact same answer of 23. One of them was direct substitution, one of them was synthetic substitution, but we still got an output of 23, saying, hey, it turns out f of 3 is 23. Really weird way to do it, because we have this 2, 1, 3, 5, and then the 23. But that's how synthetic substitution works. So I guess the first question was, which substitution method do you like better? Do you like the direct substitution method better, or do you like this kind of weird, funky synthetic substitution where we don't have to deal with the variables at all? Any thoughts? You can type into the chat if you want, but which one do you kind of like better right now? Got a couple in the chat here. Direct substitution. Okay, so someone says synthetic. Got it. Okay, direct makes more sense. Yeah, so direct makes more sense to a lot of people. One person says synthetic. That's good. And yeah, typically I would say direct as well. And probably the reason is because we're familiar with it for the why. It's something that we've done a lot of over time, where we've just taken a number and plugged in. Like, that's like solving for x-intercepts or y-intercepts. We've done this a lot. So that might be why direct substitution feels better for us. Well, polynomial long division is still relatively new for us. We just did that on Tuesday. So what we're going to do is we're going to look at we're going to look at synthetic division, which is similar to this synthetic substitution, but we're going to see if it makes polynomial long division a little easier for us. Okay, so we take our dividend and we're dividing by our divisor, x plus 3 here. The way this works is we're going to write the coefficients of the dividend in order of descending exponents. Okay, and just so you know, this is number 1 from the warm-up. So we've already solved this with polynomial long division. Now we're going to look at it with synthetic division. So first we're going to do this upside down division bar thing, and then we're going to write down all of the coefficients from the dividend. It's a third degree, so it should have 4 coefficients or 4 terms, and it does. The first coefficient is 1, then -2, then +5, -6. Okay. That's our first part right there, step 1. Then, once we write down the coefficients in descending order, we're going to draw the upside down division bar. We did that. I'll highlight that. All right, with the coefficients inside. Then we're going to write the coefficient from the divisor to the left. But the way it works with the divisor, it's a little different than the synthetic substitution. Notice with the substitution, it was x equals 3. So that's what we need to do here. We need to get to an x equals situation. So I need to take this x plus 3 here, and I technically need to solve for x. So to solve for x and put the solution for x on the left side. So what I mean by that is you say x plus 3 equals 0. We're going to subtract 3 from each side, and we're going to say x equals -3. That's going to go outside of the parentheses, or outside of the bracket here, the upside down division bar here. All right. So what we're doing is, instead of labeling all those variables and all those terms with the variables, we're just doing the coefficients only. And now we're going to complete synthetic division. What we're going to do is I'm going to do it in black now down here. We're just doing this by steps here. Remember, if you take good notes, this won't be too bad, because you can use these notes on something like the quiz next week. So the first thing it says to do is bring down the leading coefficient, and we're going to drop it outside of the box. Now we're going to multiply the leading coefficient by the value outside of the box. So we'll multiply by negative 3. And 1 times negative 3 is negative 3. We're going to write that product under the second coefficient. And then finally, we're going to add and drop the addition outside the box. So we get a negative 5 here. Okay, so that's just kind of breaking down the steps here. So drop the 1 out, multiply it by negative 3, you put it back in, and then we add the next column. So right now it might still feel a little weird, and that's okay. This is our first time looking at this. Now what we're going to do is we're going to multiply the next sum by the value outside the box. And we're going to put it back in. Negative 3 times negative 5 is 15. Write the product under the coefficient. And then we're going to add again. And we're going to get 20. And then we're going to repeat for all remaining coefficients. So we'll do 20 times negative 3 is negative 60. And then we get negative 66. The final sum is the remainder. So if you notice back to our warm-up, negative 66 is the remainder that we had up here. And we just did negative 66 again, but with synthetic division this time. And then what I asked down here is how do the coefficients of each sum, so the coefficients here, 1, negative 5, and 20, and negative 66, how does that compare to our answer from the other problem, which was the long division, which looked like this? We already know the remainder is the same, but how do the coefficients compare? How's the 1, the negative 5, and the 20 compare to our quotient from the long division answer? Do you guys see something there? Hopefully. Look at the coefficient of the x squared. That's a 1. Look at the coefficient negative 5 in front of the x. There it is. Look at the coefficient positive 20. There it is. And then finally, negative 66, negative 66. So this synthetic division, what it's doing is it's letting us solve the problem without using any of those variables, without having to keep track of x squareds, x cubes, x's, anything like that. But then we can rewrite the answer at the very end. So the coefficients from synthetic division synthetic are the same as from the long division. Okay. That's going to be true. The coefficients are the same as from the long division. Now, part B says, use synthetic division to divide x cubed minus 4x squared plus 6 by x plus 3. So we're going to do this synthetic division again. We'll do some practice here. And I notice this is a third degree polynomial, so there should be 4 terms. There's only 3 terms here, so we're missing a 0x. So when I pull all the coefficients, I want a 1, a negative 4, a 0, and a positive 6. 1, negative 4, 0, positive 6. Now this x plus 3 is the division part. I'll write that as equals to 0. And I'm going to subtract 3 from both sides, and x equals negative 3 is the number I want to use outside. So that setup might take a little bit of work. But honestly, once we get it set up, I don't think it's too bad, because now you can drop the 1, multiply it by negative 3 to put it back in, add those two numbers together, you get negative 7, multiply by negative 3 to put it back in, drop the 21 out, multiply by -3 to put it back in. And then you get 6 minus 63, -57. And there's our result of synthetic division. That went really fast. And the way we can write our answers is if we started with a third degree, our answer, our quotient should be a second degree. It should now be x squared minus 7x plus 21 minus 57 over x plus 3. And I know that I'm going to do a second degree here because I had a third degree at the beginning of the problem. So I'm going to lose 1 degree of the polynomial, and that's how I can write my solution. All right, that's how these problems work with synthetic. Hopefully you recognize this goes a little bit faster with the synthetic method. We're going to do the last one here. One more example. And it's a fourth degree, so it should have 5 coefficients, 1, 2, 3, 4, 5, and I do have that, perfect. The x minus 2 equals 0, means I add 2 to both sides, and I get x equals 2. And now I'm off to the races. 1 times 2 is 2, I get -6 there. -6 times 2 is -12, get another -6. 2 times -6 is -12, I get a 1. 1 times 2 is 2, and I get a 0. So then I end up with 1 degree less than x to the fourth, so it's going to be x cubed. And then I just go from left to right, minus 6x squared minus 6x plus 1, and then remainder 0, so that's my solution. All right, that's what these problems kind of look like. I think we can get through them a lot faster with this synthetic method, but the trick is we got to practice with the synthetic method. Okay, so what we end up with is here's our quotient, here's our remainder. Okay, so there's the quotient. There's the remainder. And then we had the dividend and the divisor up top. Okay. The last question here says, what does the result of example C say about the factor of x minus 2? It actually kind of gives away the answer because it should say, what does it say about the divisor of x minus 2? It should say x minus 2 is a factor of the dividend. And the dividend in this case was x to the fourth minus 8x cubed plus 6x squared plus 13x minus 2. So x minus 2 is indeed a factor because it goes in evenly. There's a remainder of 0. Okay. And that's how you can tell it is a factor. It's a remainder of 0. All right, now I've got some practice problems I want you guys to try. And it says look back at worksheet 21. That should be worksheet 24 or from yesterday's worksheet. But problems 1 and 2 here are from the examples from last class. So I want you to try these with the synthetic division and then open up your worksheet 24 from last time and compare your answers. So you should be able to check your answers by seeing that you have the same answers from the last time. All right, so make sure you did those 2 correctly. So try problems 1 and 2 now, and if you finish those, try 3 and 4 as well. But using synthetic division, make sure you get 0 placeholders if you need to at certain points. All right, so I've got the answers written down here that we came up with today. I hope you all went back and checked. So number 1, we got x squared plus 7x plus 7 plus 16 over x minus 2. So go back and check that. That should look pretty good, right? So that means we did it right, but we did it a lot faster, again, without that, without having to do that polynomial long division, without having to keep track of the x's and stuff like that. Hopefully this feels a little bit better for us. Problem number 2, I ended up with 4x squared minus 18x plus 54 minus 155 over 2x plus 6, right? So that looks good, right? Matches the problem from last time. And then we can talk about problems 3 and 4 in just a second here. Okay. So any questions on problems 1 or 2 there?
Wait, why does why does the x cubed disappear?
Oh, why does the x cubed disappear here?
Yeah.
Because what happens is we're dividing, so whenever you're dividing by at least an x. So that means you're going to end up with 1 degree lower. Just like when you multiply two numbers, you multiply x times x, so you get an x squared. Same thing happens when you divide. You're saying I'm taking an x away from this. So we're going to be 1 degree lower. Okay? Hopefully that makes a little bit of sense. It's a good rule of thumb just to remember that when we do the division, we should end up with 1 degree lower. So this was an x cubed, now it's going to be an x squared down here. So that's how I got 4x squared minus 18x plus 54, and then our remainder. All right. Any other questions there? You guys double check this on worksheet 24 to make sure we did it right. I want to make sure we got the same numbers as last time. So it turns out that when we did this right here, we're trying to figure out x minus equals negative 3 is our synthetic division part. We divided by 2, and what ended up happening is we used a number that was half as big as what we needed to. So all these numbers, 4, 18, and 54, are exactly twice as big as the actual answers for the quotient. 2x squared minus 9x plus 27. So that's why we got the same remainder, but we ended up with something a little different. So technically, this is like only because we did x minus 3, or x plus 3 instead of 2x plus 6. So it's really weird to think about there, but synthetic division does have some limitations. So polynomial long division is going to work every single time. Synthetic division is going to give you some trouble when you don't have a simple x plus or x minus. As seen by number 2 here. Because every answer in the quotient was exactly twice as big as it was supposed to be. So we would technically need to divide all those by 2 at the end to get the correct quotient answer. That's one way we could deal with that. But it can get really tricky if we had something like a 3x plus 4 or a 5x minus 7 and we were trying to divide by one of those. It's going to keep getting tricky. So for those types of problems, it might be better just to stick to polynomial long division instead of synthetic division. All right, and that way we won't get any mistakes on the polynomial long division. But for the rest of those problems, I really like synthetic division because I just do addition. I don't need to worry about subtraction, distributing the negative. I don't need to worry about any of the terms, the x squareds, the x's until the very end. So a couple of reasons why I like the synthetic division more. All right. Let's try the last couple of problems here. X cubed plus 4x squared minus x minus 1. Divide that by x minus 2. And then we have x to the 5th plus 16x cubed minus 1. So this one's going to need some placeholders because we're supposed to have 6 terms here. We only have 3. So that one will definitely need placeholders. But try those last two, and then you can get started on the assignment if you want before we go over these last two. But try them out now, and we'll talk about them in just a minute here.